Okay, so this is Algebra 2, Chapter 2, Section 3, linear functions and slope-intercept form. So, uh, first thing the book talks about is the concept of a slope, and the symbol usually associated with slope is lowercase m. I have no idea why it's lowercase m. They've done research onto this and they really don't know. Think would be s, but it's not. And what slope is we have a line, a straight line, and a straight line moves in 2 dimensions. A straight line moves in 2 dimensions. A straight line moves in the vertical direction, so the vertical would be the y-axis up and down, and in the horizontal direction, which is x. There is a z dimension, but that doesn't apply to this particular lecture. And when we have a line, the slope is the vertical change I'm going to write the triangle symbol, that means change, is the vertical change in y as the line changes with x, the horizontal change. So this line is moving up some direction vertically from one point to the next. So this is from the first point to the second point. We would call this x1 for the first point, y1, and we would call this x2, y2 for the second ordered pair. So as it changes from the first x to the second x, that's the horizontal change, the blue. That goes from y1 to y2, that's the vertical change in y. So what the slope is the vertical change over the horizontal change. So slope, we call it rise over run, which is the vertical change, the change in y, over the horizontal change, the change in x, which is the second y coordinate minus the first over the second x coordinate minus the first. y2 minus y1 over x2 minus x1. This is slope. Vertical change over the horizontal change of a line. Slopes always apply to lines. These are linear functions, or linear equation. Alright. Different types of slopes. The first type of slope, we can just have a positive slope. And a positive slope occurs when your slope, which is slope, but we're going to call slope m. Slope is greater than 0, meaning it's positive. When we have a slope greater than 0, we have a positive slope. And when we graph a positive slope, or a line with a positive slope, your line is going to go, as you go from left to right, your line is going to have a positive vertical change. It's going to go in the upward direction as you go from left to right. This is always going to be from left to right. Positive slope, your line is going to go in the upward direction as you go from left to right. Your slope will always be greater than 0, so 2, 3, 4, 5, 6. Then we have negative slope. Negative slope. And negative slope, your slope is going to be less than 0. Your slope is going to be less than 0. So as we go from left to right, our line is going to go in the downward direction, or you can think of it as falling. The book says falling. As you go from left to right. Negative slope. Your slope will be negative. It would be a negative number as you go from left to right. So when you see the slope of a line, whether it's positive or negative, or if it equals 0 or if it's undefined, you kind of have a gauge as to what the line is actually, what it looks like as you graph these things. Then we have 0 slope. And this is when the slope equals 0. And when we have a slope that equals 0, we have a horizontal line. When your slope is 0, that means that your y doesn't change. Your y's are going to be the same number over and over and over again. Your y's doesn't change. Let's say this is 1. So this say it's 2. Throughout the course of the line, your line is going to stay at 2 the whole time as a y. So this would be x1, 2. This would be x2, 2. Your y never changes. This would be x3, 2. So when we write the equation for a horizontal line, since the y never changes, your equation would be written as y equals 2, because that's the point at which the y never changes when you do a horizontal line. And remember, even though it's left to right, it works both ways, but we're always going to consider these things from left to right. You can think of slopes as right to left, but once you do that, you got to understand that everything switches. And we'll talk about that later in life. Alright, undefined slope. Okay. When we talk about undefined slope, M is undefined. What does it mean to be undefined? I'm going to talk about that in a moment. And when we talk about an undefined slope, we're talking about a vertical vertical line. So as we do our vertical lines, let's do our 2 again. So 1, 2, we have our line at 2. Again, in the case of a vertical line, the x's doesn't change. So it's going to be 2, y1, 2, y2, 2, y3. The x component, the x coordinate never changes on a vertical line. So when we write these guys out and we say what as an equation, we say x equals 2. And again, left to right. Okay. All right. So in terms of what a when we do the equation, the slope equation for horizontal and vertical lines. So for a horizontal line, or zero slope, when we do our rise over run, which is our change of y over change of x, which is y2 minus y1 over x2 minus x1. y2 minus y1 will be 0 in the numerator over x2 minus x1, which gives me a slope of 0. 0 divided by anything is always 0. So when we have a 0 slope, our slope will be 0 every single time. When we have an undefined slope, or a vertical line, our slope is undefined, or we have a vertical line. So when we do the same equation, change of y over change of x, which is y2 minus y1 over x2 minus x1, it's going to be y2 minus y1 over 0. Now, we can't divide by 0. If you grabbed your calculators and tried to divide by 0, your calculator would say undefined or does not exist. So you can't divide by 0. So we would have undefined. Alright, so vertical slopes are undefined because the 0 is in the denominator. And the slope for a horizontal line, the 0 is in the numerator. And we have a slope of 0. So undefined, slope in the denominator, vertical. Horizontal line, slope is 0. 0 is in the numerator. These are all graphs of lines, so we could call these linear equations or a linear function. We have both of them. So a linear function, the book says, is a function whose graph is a line. And it says you can represent a linear function with a linear equation. And a linear equation is a representation of a function of a linear function which uses an ordered pair. In the form of x and y. Okay. We have stuff in slope-intercept form, which is a form of an equation. So slope-intercept form which is the most common of all the linear equation. Intercept. Slope-intercept form is a particular equation of a line. So it's an equation of a line. And that equation is in the form of y equals mx plus b. This is where y is the y-coordinate. X is the x-coordinate. M is your slope. And B is your y-intercept. I'm going to talk about what y-intercept is in a second. B is your y-intercept. And you can get B like this. Before we get there, so slope-intercept equation of a line in the form of y equals mx plus b, where y is your y-coordinate, x is your x-coordinate, m is your slope, b is your y-intercept. Okay, what is y-intercept and x-intercept? Alright, let's start with the x-intercept first. X-intercept. X-intercept is x when y is 0. X when y is 0, so it's in the form of x 0. Essentially, it's when the line crosses the x-axis. When the line crosses the x-axis. And we also have the y-intercept. And the y-intercept is y when x is 0. And it's in the form of 0, y. But in slope-intercept form, y is the same thing as saying b, so we can also call it 0b. And this is the part where your line crosses the y-axis. Where your line crosses the y-axis. So, x-intercept, x when y is 0, used in the form of x 0, it is a part of your line that crosses the x-axis. Y-intercept is y when x is 0. So the ordered pair looks like 0y. In slope-intercept form, you can say 0b. So this is slope-intercept form. And it's the part of the line that crosses the y-axis. Okay, so let's go through do the problem examples, and then we'll do the got it number 2. So actually, let's back up. We didn't do the got it number 1. Alright, so got it number 1. So this is 1a. They give me 2 ordered pairs. They give me 5, 4, and they give me 8, 1. And it says, what is the slope of the line that passes through the given points? So we're going to use the slope formula. And slope is going to be rise over run, which is y2 minus y1 over x2 minus x1. So it all depends on what you call your x2s and y2. So if we call this x1, y1, we call this x2, y2. So when we do this, it would be 1 minus 4 over 8 minus 5, which gives me negative 3 over 3, which gives me negative 1. So slope equals negative 1. Okay. For number 2 or b, so we have this is a negative slope. For b, again, rise over run, y2 minus y1 over x2 minus x1. In this case, our ordered pair is 2 and 2 and negative 2 and negative 2. Let's in this case call these my x1, y1. We can call these my x2, y2. It doesn't matter which one is which as long as you're consistent with which one are your 2's and your 1's. So in this case, it would be 2 minus negative 2 over 2 minus negative 2. Remember, that's the same thing as saying 2 plus 2, so that's going to be 4 over 4, which equals 1. So in this case, we have a slope of 1. And then for C, we have 9 and 3 and 9 and 4, negative 4. We can call these x1, y1 and x2, y2. This would be negative 4 minus 3 over 9 minus 9. This gives me negative 7 over 0. So we have an undefined slope. Undefined slope. So in this case, we have a vertical line. And we have a vertical line at 7. Negative 7. Negative 7. Okay. Alright, so that's slope. So going back to the next section. Alright, writing linear equations. So in the part A, they tell me that we have a slope of 1/5 and we have an intercept. The y-intercept is 0, negative 3, meaning this is where it crosses the y-axis. So this is the y-intercept. So when I graph this, since I know where it crosses the y-intercept, I can say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I know that it crosses the y-axis at 0, negative 3. Oh, that's just one of the equation. They want the equation. Alright. Alright, well here's the equation then. We put this in the form of y equals mx plus b. Right? Remember, this is your y-intercept or your b. We already have our slope, so we just substitute. The slope goes here. The y-intercept, which is negative 3, goes here. So when we do our equation, it's going to be y equals 1/2 x minus 3, since it's a negative number. And that's all she wrote, folks. For part B, we have a graph. And they're saying based off of the graph, one, 2, 3, 4, 5. So we have a line here, have 4, and then we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we have this at 1 and 1. Okay. Okay. So this is 0 and 4. This is 1 and 1. So the first things first, we got to find our slope. So we got to find the slope. Remember, that's rise over run, which is change of y over change of x, which is y2 minus y1 over x2 minus x1. You don't have to write all of this stuff out. This is just for, teaching purposes. I'm going to call these the ones up top and the bottom ones as the 2's. So 4 minus 1 over 0 minus 1, which gives me negative 3 over 1, which is equal to negative 3. So what does negative 3, a slope of negative 3 means? It means that if we break it up into negative 3 over 1, that means in the vertical direction, I'm going to put the negative in the, this is all from left to right. In the vertical direction, it's going down 3. And in the 1, it's positive, it's going to the right 1. So I'm going to go down 3 and to the right 1. So if we look here on our line, we go down 3, 1, 2, 3, and then we go to the right 1, and that's our next point on the line. Down 3 to the right 1. Down 3 and to the right 1. As you go from left to right, this is from left to right. That's the first part. We found the slope. The second part, the y-intercept. So remember that the y-intercept is in the form of 0 and b. It's y when x is 0. We already have it given to us. So this is, 0, 4. So our y-intercept is 4. So we have a slope of -3. We have a y-intercept of 4, positive. So our final equation is going to be y equals -3x plus 4. Y equals -3x plus 4. Alright, so let's do the two got it's. They want to know the equation of the line, so this is 2a, where we have a slope of 6 and your y-intercept is 0, 5. Again, remember it's y equals mx plus b. So we're going to substitute 6 for slope and 5 for the y-intercept. Y equals 6x plus 5. In terms of the equation for b, we have an y-intercept at 0, -3, so that's one of our coordinates. So this is our y-intercept. We also have another ordered pair at -2, -2. So we'll do our rise over run, which is y2 minus y1, x2 minus x1. Let's call the 2's, these guys my x2's and these guys my x1's. So this is going to be -2 minus -3. And this is going to be -2 minus 0. So this is -2 plus 3, which is +1. -2 minus 0 is -2. I'm going to put that negative in the numerator and say it's going to be -1/2. -1/2. So what does that mean? As we go from left to right, it's going down 1, and it's going to the right 2. Down 1 and to the right 2. So let's see if that's the case. Down 1 and then to the right 2. Nice. Alright, so this is our slope. Slope equals -1/2. And then the y-intercept is given to me. Remember, the y-intercept is y when x is 0. So my y-intercept is equal to -3. So when I graph this, it's going to be y equals -1/2 x minus 3. So for the C part of the reasoning, which is actually pretty good, they ask you if I use a different point on this line, do I get a different equation? And the answer is no, you don't. Not in slope-intercept form. Any 2 points along this line will give you the same slope, and it will also give you the same y-intercept because that never changes. So the answer would be nope. It will be the same. Okay. So writing equations in slope-intercept form. This is 3a. I'm just going to go right to it. They give me this equation, 3x plus 2y equals 18. We want this in slope-intercept form. But remember, slope-intercept form looks like this. Y equals mx plus b. Notice that y is all by itself. There's nothing multiplying y. In this case, we have something multiplying the y. It's 2. So we have to get rid of that and also move that x to the other side. So the first thing I'm going to do is I'm going to subtract 3x from both sides. And that gives me 2y equals, I'm going to put the negative 3x in the front. Negative 3x plus 18. So it looks really, really close to y equals mx plus b. Now I just got to divide everything by 2. And then if I divide everything by 2, I get y equals negative 3 halves x plus 9. This is my line in slope-intercept form. So that would be it. 3b, they give me negative 7x minus 5y equals 35. The first thing I'm going to do is I'm going to add the 7x to both sides. This negative sign stays with the 5. So it's going to be negative 5y equals 7x plus 35. Then I'm going to divide both sides by negative 5. So then that cancels, and that's y. I have negative 7 fifths x minus 7. And that would be my answer. I divide everything by negative 5. Okay. Pretty straightforward. You add the x term to both sides, and then you divide by whatever's multiplying the y. Well, how do I graph these things? Graphing these things are actually pretty cool. They're pretty neat because you can you automatically get one of the points, and then you can use the slope in order to find the other one. So what does that look like? They break it up into steps. So let's start with this graph here for number 4. They want us to graph 4x minus 7y equal 14. First thing I gotta do is turn it into slope-intercept form. Subtract 4x from both sides. That gives me negative 7y equals negative 4x plus 14. Then divide both sides. Why gotta be a 7? By negative 7. So that gives me y equals 4/7 minus 2. Ugh. Alright. So let's graph this. Oops, 4/7x minus 2. Alright. So we are ready. So in order to graph a line, all I need is 2 points, right? 2 points define a line. So they give me the first point because this is in slope-intercept form. I already know what one of the order pair looks like, and it's the y-intercept. Remember, y when x is 0. So x is 0 and y is -2. So I already have one of the order pairs. So I just have to find the other one and then connect the dots. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that's my x-axis. That's my y-axis. I already have one of the points. I have the y-intercept. And it's given to me from the equation itself. So 0 and -2. That's my first point. Nice. So now I'm going to do the rise over run. My slope is 4/7, and it's positive, which means that I'm going to go up 4. So positive means I'm going up, negative would mean I'm going down. In the case of the denominator, I'm going to go to the right 7. Up 4 and to the right 7. So 1, 2, 3, 4. So this would be my up 4. And then I'm going to the right 7. So up 4, 1, 2, 3, 4. And then to the right 7. 1, 2, 3, 4, 5, 6, 7. Up 4 and to the right 7. Up 4 and to the right 7. So then I can connect my dots. I know I don't want you to be red. Up 4 and to the right 7. Okay? First step, get your slope from the equation. Oh, first step, turn it into slope intercept form, y-intercept, slope-intercept form. From the slope-intercept form, you can get your y-intercept. So you graph your y-intercept. It's always going to be on the y-axis. It's always on the y-axis. After that, you can use your slope to get the second point along that line, and then you connect the dots, and this is your graph. A lot of times we label our graphs. So right next to your graph, you can write what the equation is. Y equals 4, 7x minus 2. It would be nice if you did, and then put a little box around it to tell me that's what the equation is. Okay? Alright. That is graphing. Okay, so that's this section. I hope you have a great rest of your